Hello everyone, and thank you for joining us today for our HashiCorp webinar, where today we'll be discussing the benefits of cloud networking automation for service providers. My name is Connor Beechnor, Senior Field Marketing Manager here at HashiCorp, and I'll be your moderator for today's session. And today I'm delighted to welcome Ricardo Oliveira, who's one of our solution engineers here at HashiCorp, and will be your presenter today. And he's joined by Christoph Poole, who's one of our staff solution engineers and console specialists, who'll be able to help answer any questions. In terms of the agenda, Ricardo will start with a presentation and whiteboarding before getting into a quick demo. And after about 50 minutes, we'll wrap up for some Q&A. If you do have any questions throughout the presentation, please post them in a Q&A box provided, and we'll answer those during the session or at the end. Lastly, please note this webinar is being recorded and we'll send that out to everyone via email after it's been processed, usually within a day or two. So with that, over to you, Ricardo.
Hello, everyone. My name is Ricardo, and I'll be taking you through this presentation. Thank you very much for the introduction, Connor. Now, like Connor said, this is the agenda. We'll go talk a little bit about the company, give you guys a bit of an overview of who we are and what we do. Also, why do we need automation and why we're talking about it in terms of network automation. And also then I'll explain a little bit of what has changed in terms of the delivery of applications in a dynamic environment, right? And how Consul helps you address that. So to start off now with just tell you a little bit more of HashiCorp. Usually you know us more from our products, really. So HashiCorp started in 2012, and over the years, as you can see, we've been growing quite fast. Now have reached more than 1,000 employees, 8 of the Fortune 10 companies, and at least 300 of the Global 2000 companies, right? Again, you may know us better from our products such as Packer, which we use to create images, Vagrant to manage, that developers also use to manage virtual machines. We have Terraform for provisioning infrastructure, Consul for network automation, service discovery, and so on. We'll see that in a bit more detail in a moment. Vault for secrets management between applications. We added a new product now with HashiConf called Boundary, which is to manage access management, so for secure access management in a dynamic world. We also have Waypoint and Nomad. So Waypoint is to manage application development workflows, while Nomad is our orchestration solution, which works quite well if you're having the journey from virtual machines to microservices and planning to add Kubernetes as well. Nomad is a great add-on to that, right? So these products, what they do altogether really is that they enable cloud adoption and automation of everyday processes, right? And if you notice, one of the common mantra across all of these tools is that we like to address workflows instead of technologies, right? It's about how you work with the tools. It's not about what technologies lie underneath, right? So if we have a quick look at HashiCorp's whole product suite, this is how we scope more or less the role of each product when you're deploying an application. So you start by having your infrastructure team to deploy infrastructure using, infrastructure as code using Terraform. You have then to manage all of the secrets associated with that, with your applications and with your infrastructure with Vault. And Consul helps you connect everything together, and Nomad is what addresses the runtime layer of being able to run your applications and scale your applications, right? So this is, in a nutshell, okay, what HashiCorp does. Now, going a bit more, being a bit more specific on our presentation, we'll have a bit of a look at network automation and how it has been able to help several of our customers. Okay, so if we look at this year, everything that's going on, especially this year, data services are allowing customers to connect with each other so that they can catch up, share experiences, and so on, right? You've been through this. And it happens that nowadays your customers have the same expectation of their data services, like uptime and so on, as they have of running water and electricity, right? If anyone internet drops, the first thing they do is they call their ISP, right? So the expectations are there, they are real. So this poses several challenges, and from these, I've picked three key challenges that happen on our day-to-day. One of them is keeping up with innovation. So new technologies appear every day, and companies need to keep up with the latest generation. As an example, 5G that has just come up is not just about having cell towers ready or anything like that, but there's also all the backend services that need to be able to cope with the extra load, right? Then companies are, fully or partially adopting some kind of cloud service. So you're having now to manage a hybrid infrastructure, and you're seeing a lot more holes and connections between what was your precious premise. Now you have to connect it, and it becomes a bit more fluid as you connect these over to your cloud services, right? And third, governance, risk, and compliance, which means that you still have to think about how you keep this traffic across your hybrid cloud secure, and you're able to control permissions between all the different applications and services, right? So we have these three key challenges, right? And bearing these in mind, if we look at the three objectives that automation tries to solve, is that it tries to reduce OpEx, right? By reducing, you need to reduce OpEx, you have this objective, but at the same time, you have to keep up with innovation, right? So it becomes quite challenging. At the same time, you have to scale to meet the demand using hybrid cloud, but then you need to manage these different types of infrastructures, right? And you're being always asked, to be faster and not be a hindrance, but actually an enabler to deploy applications to have a faster time to market. However, you can't put compliance in risk, right? You can't just put the company at risk by trying to be faster with this. So let's look now. Let's look a little bit at the landscape of what we want to automate, right? So the tools that we use here in our infrastructure, you have usually load balancers, proxies, firewalls. You have API gateways that you want to manage these configurations. And at the same time, you want to be able to integrate these with your certificate authority, IAM, application performance monitoring, logging, or even your ticketing system, right? Now, if we look at from the ground up of how we are able to connect all of these, right, from bottom to up, we see that you have to connect all of this infrastructure with a sort of a platform, right? You've got Azure, GCP, or even just your cloud, right? Now you're being asked to support this platform as a service across your company, okay? And you have to start supporting bare metal machines, containers, serverless, virtual machines, and so on. And you have to think about how we're able to keep track of applications across all of these platforms. How do we enable traffic also across all of these applications, and how we are able to automate all of these components so that they work together. So that's where Consul comes in, right? So Consul is your single control plane for cloud networking. It automates and controls the data plane with a central service registry, has unified support across several different types of environments, and it simplifies your operations and your workflows, right? So Consul is there trying to make your life easier, your workflow easier. So let's look at a bit more of what other, let's say you have all of these categories, right? But we need to also put a few names to this. So for example, your load balancers can be F5 or Nginx integrated with Consul, which at the same time, as soon as your application spins up on any of these platforms, gets connected with your monitoring system, right? or with your secrets management solution, and so on. Okay, so this is what Consul becomes, so the glue between all of these different systems. All right, so Consul primarily addresses these three key use cases. All right, so it provides a service registry and health monitoring, so both of them together. Also, network middleware automation. It enables middleware automation, as we'll see today, and also provides you a way to establish a zero trust network with service mesh. We'll also dive a bit deeper into that later on. Right? It's a highly scalable application, and we've seen it being used with over 50,000 agents. Right? Wait. All right. So you don't need to just take our word for it. These are only our public customers. As you may know, we have got a lot of more companies using our Consul product. And these are just some of our partners. If you follow that link there, you'll be able to see how these partners integrate with Consul. And these are just a few of them. Right. So let's look at the current landscape of how we deliver applications in a dynamic environment. So we have a dynamic environment and are trying to deliver an application. What happens, with little or no automation? So first we start with the application developer, which has a new application, and he wants to spin that up, right? It can be a new application or a new version of the application. Okay, so what does he do next? He opens up a ticket, right? So he submits a ticket. The server admin then sees that he needs to spin up a new infrastructure, a new database, or something like that. And then he needs to actually, submit another ticket to get an IP address to his new infrastructure, to the network administrator, which then may need to also submit another ticket to get a new DNS endpoint, which finally also gets him a VIP, or also creates a generic FQDN to access the new application, right? So you see these tickets going backwards and forwards, right, between application developer, server admin, network admin, and security operations, because there's just a lot of things to do and a lot of things to automate if you want your application to become available in the cloud. And by the time that you reach that the ports actually are open to the new application or that new version of the application, right? The marketing campaign is probably already finished, right? So it's been 6 months already, and it is just not good enough, especially in this dynamic world where you need to be able to respond a lot faster to this. Right, so this is where Consul comes in. And we will look at, I'll now do a bit of a whiteboard to explain how this dynamic service registration and discovery works. Okay, so if I go here, give me a bit of a moment. Okay, setting up pen. Okay, so let's look at what we usually have. So we've got usually cloud or someone external needs to access an application. What do? You have a load balancer, right? So it always goes from here into your infrastructure. You have a DMZ. So this is just usual stuff that you do. And then that connects usually to some sort of a virtual machine, right? Now, in this virtual machine, you have several services, right? Let's say I have service A, B, C, and D. This is usually how it works. Let's say, for example, A would be your web service, and B is your backend service that actually connects to a database, right? So pretty standard stuff. Now, the way that this traditionally works is that A connects to B, and then everything works fine. Now, the problems here arise when you actually want to start to scale this, right? You want to add more virtual machines, right? So what you do, you need to configure another IP address here on the load balancer, so on. So again, more tickets, and so on. What if you want to add another service? It's yet another load balancer, right? and so on. So you can see how this does not scale every time you want to add a new product, or it's also a waste of resources every time you want to just add more capacity to your web server, but actually your backend is not impacted, right? Basically, you start resorting to vertical scaling and things like that. Now, what happens is that people started talking about microservices, right? And this is great because it allows you now, if you are application A, sorry, let me just go a bit more. If you have now application A and application A is your web service, which means now you can scale this one a lot easier without having to scale your backend, right? However, I said this can be a virtual machine or A can be several containers. Now, when A wants to talk to B, right, how is it able to reach out to B? Okay, well, in our world, we know how we fix this. We just treat it like we did before. So we can add a load balancer here. And now we also add a DNS and an IP address here, something like that. And basically, then you're able to also scale B, right? You just have to reconfigure this load balancer all the time. Now, what if you also have the service B here in a different cloud, different infrastructure, right? And you want to scale it. What happens? You have now yet another load balancer, and then you have like a load balancer that is able to cross regions and so on. And you assign yet another DNS endpoint here so that A is now able to reach out to B. Okay, you see how this can cause a few issues, right? One of them is the number of IP addresses here to make sure that this load balancer is resilient. It may not be, and this DNS needs to be dynamic, right? Then you have configurations of the load balancer that need to be managed every time there's a new service, right? How every time you scale, how these IP addresses keep being added to the load balancer and also removed, right? So it's not just about adding IP addresses, you also need to be able to remove these. And this is for what we call, of course, is 2x traffic. Now, the way that Consul resolves this, right, is that it provides you with a common registry. Okay, so Consul manages this registry, and every time one of these applications spins up, any instance of these services spins up, it registers it in this registry. So, okay, and what happens when A now wants to talk to B, A can just query this global catalog to discover where B is, right? So B just asks for b.service.consul, and then it is able to find all of the IP addresses that B has, right? And that is done by a DNS. You can also use the HTTP API. That's not a problem. So that it has not just the IP addresses, but also a lot more information about health status or more information about which port to connect to. Now, when, let's say, one of these applications, if one of these applications fails, one of these instances fails, what happens is that Consul automatically removes it from, right, if this was 1 and 2, automatically removes it from the list and stops returning that. Okay. Okay, so you have now a dynamic DNS endpoint with DNS resolution with health checks, right? So it automatically gets updated. Right. So, and this is the basic premise of how Consul works, right? If I go over here, sorry. Okay. So, all right. Now let's on our next step, Okay, so actually, sorry, before we move along, just to show you a little bit of how this works, how you can discover several, how Consul actually returns this every time you do a DNS resolution. So if we go here to the right side, you see my bastion, right? On this bastion, if I try to resolve, for example, this service, you can tell that it returns two different IP addresses, right? So returning these two IP addresses, and if I do it again, right, you can see that it will start randomizing between these two. So I only have two. If I had 4, 5, 6, how many instances I have, these would be then randomized like this. Now, sorry, if we go into another scenario, which is I want for all of service A to actually resolve this instance of service B, which is running, I don't know, let's say on-prem. And if it fails to actually resolve something over, on data center 2, for example. So this is on data center 1, and you want it to resolve over to the second data center. We have something called global queries. So a global query happens something like this. So I've got this JSON that configures a global query, right? So all it does is that it matches on the name of the service and gives me as a failover the nearest data center that corresponds to that. So let's, before I do that, right? It means that if I do, if I ask my DNS, my console DNS for local counter.query.console, which is just a service that's running, it returns empty. However, if I configure this, right, I get an ID of the new query that has been configured. Now that if I do another DNS request, I can see that it returns, the one that's more local to me, and it will always return the same one. Right? If what I do is, sorry, let's see. Okay. If now what I do is that I'm going to go on and kill that one. I've got these running just on Kubernetes clusters. So I can do like this and I'll just delete that deployment. Yep. Okay. Counter. Now that I'm deleting, I'll see that it just automatically returns the one that's running on a different data center. Right. So basically, I have two console clusters paired, and as soon as I killed the counter on one side, it automatically now is resolving the IP address of the other side. Right. So if you have any questions about that, please feel free to post them on the chat or on the QA. Right. So let's have a look now at network middleware automation infrastructure and why do we need this? So if we take a look back here, right? This works, as we've seen, quite, there we go, quite well, but we still need some infrastructure. We can't just get all of our firewalls and move them over to the cloud or any of our load balancers. Right. So usually, this is great, and what I just presented works fine for east-west traffic, but we also have the notion of north-south traffic, right? So that's every traffic that comes from the outside, right? It needs to go through a firewall, then it goes through a load balancer, and then finally gets over to an application like, I don't know, your web server or something like that, or another application. Right. Now, there are a few more things connected to it. So these are usually like your own fixed load balancers that you have here. And let's say you also have like application performance monitoring attached to this. You have your logging facility as well attached, and you want all of these to be connected. Now, as I explained before, the services, when they come up, they connect to the registry, right? And other services can then discover them. At the same time, right, if we have here console, every time that one of these services comes up, like we said, they register themselves with this control plane. Right now, the load balancer or the firewall can also be listening for these events. So you have like a pub, so they can publish their status and their configuration, and then your firewall and your load balancer can subscribe to these updates, right, and update each other straight away. So the same thing is valid for your application performance monitoring and for your logs, right? So these would also be subscribers. So we have this integration done natively with several different companies, right? We have the Cisco ACI, for example. We've got also integrations with Palo Alto, or also for your F5 load balancers, right, and etc. So let's have a quick look of how this achieves, for example, on the F5 case, right? How can F5 load balancers automatically update when there is a change, right? Where is it? Okay. So what happens now that when you're trying to deliver an application, let's say you're using an F5 load balancer. So now your application developer has a new app. The server admin is able to provision infrastructure using Terraform, right? So with Terraform, they can configure the F5 or the AS3 service, which is application services extension that is a product from F5. So once these services are registered with Consul and AS3, Consul informs AS3 of these changes of these active services that the developer just deployed, and then AS3 will be updating the big IP services, right? So all of this now happened with no real ticketing system, so with very little wait, and it has happened with the agreement of security operations, network administrators, and the server admins, right? Because you've established this workflow, you've validated and authorized the application developer to do this, right? So every time he has a new version, or when he spins up, 3 or 5 versions of his application, he doesn't need to always go through change control or through change windows, right? Every time he wants to deploy something. So this is how you'd be able to integrate. So automation works great in the F5 LAN because you can provision your Nginx controller or BigIQ. You can configure all of that with Terraform, and Consul can also help you automate all of those products. All right. And this is just for the F5 use case. Right. Now, let's say that you don't have an F5 and that you want to still be able to update any type of infrastructure. That's why recently we've launched something called Consul Terraform Sync. So that allows automating basically everything and anything through Terraform. So every time a service gets created or spins up, or an infrastructure is spun up on the right-hand side, right? So the service comes up, registers itself with the catalog, and then Consul Terraform Sync will be pulling information from this catalog. When the Consul Terraform Sync detects a change, it can execute some Terraform code, which will then change your network infrastructure, right? So with this, you have automatic changes through an approved process being applied to your infrastructure, to your logging, and so on. And the power of this is that Terraform supports many different types of infrastructure, right? If we have just a quick look at the providers page, you can see it's just on the networking page of verified providers. It has quite a wide range of support. So as soon as the application gets deployed, to be able to, or a new version or a new instance of the application gets deployed, to be able to run Terraform code that does all of the configuration of anything is actually quite powerful. All right, so please check out our website for Consul Terraform Sync. Right, so, and in our philosophy of crawl, walk, run, right? So crawling being the DNS resolution, walking being network automation, these would be on the running part, okay? To be able to use the service mesh and have a zero trust or a low trust network across your premise. Now let's have a quick look of how that works. So if I go, sorry, just trying to, okay. All right. So another thing that we enable for applications that merely register themselves is for them to be able to connect. So, and Consul Connect works in the following way. So it means that when you have service A wants to connect with service B, right? It does so through a proxy. Okay, so A goes through a proxy, which then goes actually into another proxy, which then goes into B. Now, this proxy is configured by the Consul agents that are either running on its own VM, right? Or it can also be just configuring different containers. So these would be, for example, Kubernetes, something like that. Now, the way that this happens is because Consul agent will then configure the proxies with certificates. So Consul will be the certificate authority, which means then service A will have its own TLS and identity, and service B will also have its own identity, right? And now that you've established some kind of authentication, right, it means we can also have authorization through intention. So now we can say that service A can connect to B, but that B cannot connect to anywhere, right? So this is what we call intentions. So when service A wants to connect to service B, it goes through the proxy. The proxy checks, has the certificate here, and when it connects to the other side, to the other proxy, it presents its own certificate, right? So this is a TLS communication. This proxy will check with Consul agent if it's actually able to connect. If not, it will just disconnect and nothing will happen. So it will check for the intentions that are in the Consul registry. If the connection is allowed, it establishes an MTLS connection, right? So this becomes like an MTLS tunnel that then allows the traffic from service A to service B. And service A is just connecting to a local host port, same thing for service B, so they don't need to be managing any of this. Consul will take care of these connections for them. All right, so this is usually done through leveraging Envoy. Right, so using the Envoy proxy. And that means that you can also then add observability to your applications through things like Zipkin or Jaeger. Right. All right, and I think that's it. We do have an integration with regarding certificate authority with Vault. So if you want, you can have Vault, which is one of our products that takes care of managing certificates connected to Consul and managing these identities. All right, so This works very well for east-west traffic, and if you'd go out and start putting all of your applications into a mesh network, right? However, we know that and are quite aware that that's not feasible. So what we did was we came up with a concept of several gateways in Consul. First, something that we call an ingress gateway. Oops, sorry, my pen is failing here. Okay, so what an ingress gateway does is that it allows connection from the outside, right, into this whole mesh world. So let's say if you have if you have your backend here, let's say your backend is a service running somewhere in the service mesh, this perimeter, right? What happens is that the ingress gateway will then be able to enforce intentions to allow communication from the outside. This is also TLS encrypted, and here will be MTLS encryption from the outside to this backend. Okay, and then as this backend scales up or down, of course, those instances will be automatically added to this ingress gateway. Something else that we have is the concept of a terminating gateway. All right, so terminating gateway is also something that would sit on the edge. It's quite big, would sit on the edge and would allow your applications from inside of the mesh to communicate outbound. So they would be able to also have an MTLS here, which then, for example, your backend would be able to access an external database, right? So let's say it is something on your own private network. Right? So the terminating gateway would be able then to communicate out via TLS or even through MTLS. Now, so this would be with the terminating gateway. Now, let's say you have a different, you have a lot more services in this mesh, and all of this is on-prem, but you also want to have some services actually running on the cloud, right? So I say here, you have your cloud network, being whatever cloud it is, right? So we're very cloud agnostic on that. So we have another concept of a gateway called mesh gateways. And these mesh gateways, right, they are able to connect different data centers. So this would be an on-prem DC1, the cloud DC2, right? They're able to connect with other mesh gateways. This is what we call mesh federation. Okay, and establish MTLS tunnels, which are useful so that, for example, your services that are running here, so let's say your web service is running here, to access your backend, you'd be able to connect through the mesh gateway to your on-premise backend service, right? And if you have, let's say, any other services running on the cloud, you can even, let's say, from your on-premise ingress, travel all the way through the mesh gateway, right, through this MTLS over to these services. So this now means that you're able to spin up and to scale several services in the cloud and make those available on-premise through a secure MTLS tunnel, right? All of these, of course, these connections, these instances here are highly scalable, so you should not have a problem with throughput here. Right, all good. So we're almost running out of time. If you have any questions, again, please ask them on the chat or so on. Now, Consul looks great from this perspective, but it seems that it allows you to flatten your network, right? And that's not very good when you have multiple tenants on it, and it's just not secure, right? So we need to provide a way for you to segment your network to have some sort of segmentation, right? So if we look at real quick here at, let's say, a console data center, right? So we have a console server, right? And say DC1. You can have, for example, let's say application A, B, and C, right? And you have like X, Y, and Z. And these are actually accessed and used by different teams. So let's say you have, your developer and your operations. Now they should not be able to talk to each other, right? These are two different teams, and you should be able to have different tenants. That's why we came up with a concept of namespaces in console. So you can have your dev namespace and your ops namespace, right? So these would be all safeguarded. The access to these would be all safeguarded using ACLs, for example. So we have namespaces. If you also have users, actually, so wanting to connect and manage and actually be able to see your services, we also have single sign-on. And of course, all of this connects over to your audit, right? So if we have just a quick look to what I mean by namespaces. So if I go here, you can see that these are a bunch of services I have in my demo, and we can have a namespace for my dashboard service, namespace for my web service, right? I have a token that allows me to access all of this, of course. But if I log out, right, of this with token with high permissions, I'm able to then use single sign-on and connect using my HashiCorp account. In this case, I'm using Azure AD. Right, so now it allows me to access an admin, but all of my actions are going to be recorded, right, in the audit log as well. I'm not able, for example, to access the other data center though, data center 2. So I'm not allowed to do that, but I can always go over to data center 1. All right, and that's it for my demo. So thanks everyone for your attention, and please let me know if you have any questions.
Amazing. So thanks, Ricardo, for that. We have just 2 questions that have come through. The first is, can Consul be deployed in OpenShift?
So Consul, as of version 1.9, Consul can now be deployed in OpenShift. We have worked quite extensively on that integration as well. So not only with OpenShift, but also with Kubernetes. So now you can use also custom resources to configure your service mesh.
Amazing. And my second question was actually about Consul 1.9 as well. So you've covered both in one, which is fantastic. So with that, if you do fancy learning more about HashiCorp Consul, then I really encourage you to check out our online learning platform, where you can try some of these features for yourself. And you can find that at learn.hashicorp.com/console. And lastly, just a reminder, this webinar was recorded, and we'll make that recording available on our website after processing. I'll send you a link via email once it's ready tomorrow. All right, so I hope everyone enjoyed today's session, and thanks so much for joining us. Thanks, everyone.